Okay, we're going to wrap up this notes page. Been talking about taking two samples, one from each of two different populations, and trying to compare their proportions. In the last video, we were looking at doing significance tests, comparing the proportions of two populations. I want to just talk today about how if you're not collecting samples, but rather you're performing an experiment where you might be assigning two different groups to treatments, okay? So if we're talking about an experiment, instead of checking off in our conditions that we need to say that the two samples were selected randomly, we need to make sure that we're making a statement that in our experiment, we randomly assigned treatments to individuals or to the subjects, okay, or vice versa, that the subjects were randomly assigned to treatments, either way, okay? So that is one adjustment to our list of conditions that we would need to list if we are doing experiments versus sampling. The other thing that is worth noting is if we're actually not sampling from a population, we don't need to check the 10% condition. The whole purpose of that is typically when we gather a sample of people, as we select each person, we don't throw them back into the pot so that they could accidentally be chosen again. And so we do that 10% condition to make sure, since we're sampling without replacement as we're choosing people, that we're not going above that 10% of the sample size is exceeding the population. So if we're not talking about sampling, we don't need to check the 10% condition. And if we're not talking about sampling, we also then don't need to check to make sure that any samples were collected independently of each other. So it really shortens the list of our conditions when we're talking about an experiment. We only need to comment that there was random assignment of treatments. And then, of course, we still need to check that large counts condition for both of the groups here, that those are all, should make a note here, that these are all greater than or equal to 10. So let's take a look at this example here. It says, high levels of cholesterol in the blood are associated with a higher risk of heart attacks. The question is, will using a drug to lower cholesterol reduce the number of heart attacks we would expect? Well, the Helsinki Heart Study recruited middle-aged men with high cholesterol but no history of other serious medical problems to investigate this question. Okay, now it's worth noting here that the subjects were volunteers, and that's okay in an experiment. But the volunteer subjects, they were assigned at random to one of two treatments. Okay, 2,051 men took the drug gemfibrozil to reduce their cholesterol levels, and then there was a control group of 2,030 men who took a placebo pill. During the next 5 years, 56 men in the gemfibrozil group and 84 men in the placebo group had heart attacks. Is this difference statistically significant at the alpha level of 0.01? Now remember, when we say, is it statistically significant? The answer is yes if we reject the null hypothesis. The answer is no if we fail to reject. Now I tried to fill in some of the pieces to this because these problems are generally, very large because we're doing two things here, two different treatment groups. So I went ahead and defined almost all of what P1 and P2 were. P1 will be the true population proportion of those having heart attacks for middle-aged men. We want to say like those in the study who take gemfibrozil. Okay. Now, the reason I said like those in the study is because it described that these men that they used were not selected at random, but rather they were volunteers. Okay, now P2 will be the true population proportion of those having heart attacks for middle-aged men like those in the study who take a placebo. Okay, so again with the like those in this study. Now remember, our null hypothesis is always a statement of equality. So we're going to start out assuming that the proportion of men who have heart attacks, whether they're taking the gemfibrozil or whether they're taking a placebo, would be exactly the same. So in other words, there's not really a difference. The gemfibrozil isn't necessarily helping at all, is the assumption under the null hypothesis. Now, if we look up here, we're trying to figure out if this drug is going to at all reduce the number of heart attacks. Okay, you'll notice that I had boxed in up here in red, will using the drug lower the blood cholesterol level and in turn reduce the number of heart attacks. I want to pull on that word reduce here, and I want to say, well, what we're looking to see if we have evidence in favor of is that the proportion who are in this gemfibrozil group actually would be less than the proportion who just took the placebo in terms of the amount of men having heart attacks. Okay, the alpha level is 0.01, and we're going to go ahead and walk through our conditions. Now, remember up above here, we said if it's an experiment, there actually are only 2 conditions here. I know I have 3 things listed because we almost always have 3, but we just want to make a statement here and say that the treatments were randomly assigned. Okay, that's good enough. The treatments were randomly assigned. Now, the second thing that we would generally show is we would typically show the 10% condition here. You would not need to write what I'm writing right now on the test. I'm just really putting this more for you if you look back at your notes and you're wondering why didn't we list the 10% condition. There's no 10% condition needed because this is an experiment, okay? It's only needed for sampling, not experiments, okay? And then the other condition that needs to be shown is the normality condition, that large counts condition here, and that needs to be to show that the number of successes and the number of failures for both groups is at least 10. Now, let's look at the information that we're given here. They told us that there were 56 men in the gemfibrozil group who had a heart attack and 84 in the placebo group that had a heart attack. Now, since what we're measuring is the proportion or number of individuals who have had heart attacks, that's what we're defining as a success. So 56 of those 2,051 men who were in the gemfibrozil group had heart attacks, so that means the number of failures in that group is 1,095. 84 men from the placebo group had heart attacks. That's our number of successes. We subtract that off of the 2,030, and that leaves us with 1,946 who did not have heart attacks. Okay, so this is another one of those examples, like in the previous video, where they had kind of presented the information in this table, and we could pull the number of successes and number of failures directly from the table. We can kind of do that here instead of showing n times p, n times 1 minus p. Okay, so that checks that off. Let's go on down to the n in phantoms, and let's go ahead and list the name of this test. This is called a 2-proportion z-test. Okay, the name does not change because it's an experiment. Okay, now I did tell you, please use your calculator for this. I would highly encourage you to do that. When you select that on your calculator screen, the 2-prop z-test, it's going to ask you for these 4 inputs. Remember your x1, x2s, those are the number of successes. That would be the number of individuals who actually had a heart attack within each of those 2 groups. That would be the 56 from the gemfibrozil group, and that would be an 84 from the placebo group. Okay, I'm going to report those. I'm going to go ahead and hit calculate, and that's going to give me my test statistic. That's my z-score here, negative 2.47. Now remember, this was a less than symbol here. So what we're talking about is we're talking about placing that z-score value on our curve, and we're only interested in the shading to the left. You will also notice on your screen when you run that test, it should report for you what the p-value is. So we're going to report that the p-value is 0.0068, and then we're going to do a comparison for the m in phantoms. This is where we make a decision. We're going to say since the p-value of 0.0068 is less than the alpha level of 0.01, our decision is going to be to reject the null hypothesis. So this means that we have convincing evidence that, remember this is stating in context our alternative hypothesis, that the true proportion of middle-aged men similar to those in this study is less than the true proportion of middle-aged men who were in the placebo group. Oh, I think I left something out here. I think that this should say the true proportion of middle-aged men similar to this study taking gemfibrozil is less than the true proportion of middle-aged men who were in the placebo group. Okay, so since we rejected the null hypothesis, we are going to say that these results are statistically significant at the alpha level of 0.01. Okay, that's how you run through a 2-proportion z-test. I know there is one more example here, but we've done so many significance tests, even in the last chapter, that I think you get the idea of this phantoms process. And honestly, running the calculator feature, it really helps with, bypassing the whole needing to do a pulled proportion by hand and all of that. Okay, so if you have questions, please let me know, but you will find at the very bottom of this last page, which we are not going to do